Hi and welcome back to Gaffy's Grinds. This is the channel where we take difficult concepts from junior cycle science, we break them down into small, manageable, easy explanations, and we give you some practice to help you guys master them. A reminder that you should be turning your phone off. It's a distraction. You should close any open tabs that you've got, and you should also close down any social media. And the most important thing is I'm going to give you some opportunity to practice and master content. It's really important that you actually take that opportunity, do the questions, otherwise you're not going to learn very much. Okay, in today's video, we're going to be looking at the question, how surface area affects the rate of reaction. And before we can understand this, we must first understand what surface area is. Here are two containers, where the one on the left has larger lumps and the one on the right has smaller lumps. And what do I mean? Well, here is one large lump. So in the left, you've got one large lump. And here are many smaller lumps with the same mass as the large lump. So you get the idea. So you're just breaking it up into smaller lumps. The same mass, same amount of stuff, but I've broken it up into small lumps. Okay, so the one large lump has a smaller, what we call a smaller surface area, okay, than the small lumps combined. In other words, the large lump has less surface exposed than the smaller lumps. The smaller lumps have a greater surface area because more of the surface is exposed. Okay, so it's time to do some practice. Let's have a look at these questions. Okay, so below, let's have a look at question one first of all. Below are two boxes A and B, which contain the same substance. So have a look at A and B. And you have to say in the first question, question one, which box contains a substance with a greater surface area? So pause the video and answer that now. Which one has a substance with a greater surface area? Pause the video and answer it. Okay, now I'm going to ask you to do number two and number three. So number two says, how do you know? So you're talking about answer number one. How do you know that that's the answer? And number three, how could I increase the surface area of the substance in container? Sorry, this should say in container A. Okay, so number three. So pause the video and do questions one, two, make sure you have 1, 2, and 3 done. Okay, so you should only be watching if you have done questions 1, 2, and 3. Well, which box contains a substance with the greater surface area? Answer is B. So well done. If you said B, B has a substance with a greater surface area. How do you know? Well, the answer here is that B has smaller lumps, or a better word than lump. I've been using the word lump, but a better word than lump is pieces or particles. Pieces or particles. Smaller lumps or pieces or particles. Now, so what does that mean? We could say so more surface is exposed. Therefore, it's got a greater surface area exposed. Okay, so B has smaller lumps or pieces, so more surface area, more surface is exposed. How could I increase the surface area of the substance in container A? Well, hopefully, you realize you just have to take it and break it into these smaller pieces. So, smaller pieces. So you should have definitely included the phrase smaller pieces in your answer. Now it's up to you how you describe making them smaller pieces. You could say break it into smaller pieces, smash it into smaller pieces, crush it into smaller pieces, whatever way you want to say it. But you definitely have to have this phrase in your answer, smaller pieces. All right, let's have a look at this one, a real life one. So picture A shows some steel wool and picture B shows an iron nail, or steel. Actually, I'm going to say it's a steel nail. Because it is a steel nail. Okay, got some iron wool and steel nail. They're both the same substance. Okay, so A is the steel wool and B is the iron nail. Which one has a greater surface area? What do you think, A or B? Pause the video and answer this question now. All right, so hopefully you went for A. A has a greater surface area. So the answer is A. If you said A, that's correct. Why is that? Well, if we were to zoom in on the wool, you would see it's got all these tiny little skinny fibers. So it's got iron, same as our steel. It's got steel, the same as the nail, but the nail only got this one surface on the outside. What about all of the metal that's on the inside? That's inside that outer surface. That's not exposed. That's on the inside. Whereas this is much more like shredded up, much more finely. You've got like many, much more skinny fibers. So much more of the substance is actually exposed because it's narrower or it's smaller. The particles are thinner or narrower or smaller. So it has a greater surface area. A has a greater surface area. Well done if you said that. All right, let's go back and see how this is going to affect a chemical reaction. Okay, well, in this case, the lumps represent a particular chemical. They represent a chemical calcium carbonate. Okay, so the lumps represent calcium carbonate in both the left and the right. So what we want to learn is how does the surface area of the calcium carbonate lumps affect the rate of the reaction when they react with these hydrochloric acid particles. So here are some hydrochloric acid particles. Okay, so a reminder that the lumps represent a substance called calcium carbonate, CaCO3. This is the same as limestone or limestone chips, or what we call marble chips, calcium carbonate, CaCO3. And the red particles represent oxygen particles. Sorry, not oxygen, hydrochloric acid, HCl, hydrochloric acid, shown by the red particles. So we've got calcium carbonate and hydrochloric acid particles. If these HCl particles collide with the calcium chloride particles with enough energy, then successful collisions will take place. So from our last video, we know that the particles must collide for a reaction. So I'm showing that these particles are moving with these black motion lines. This shows that the particles are moving. And if they're moving, then they're going to collide. And if they collide with enough energy, then we get a successful collision, then a chemical reaction is going to happen. So some of the particles will collide with the surface of the calcium carbonate, as you can see here. Some of the HCl collides with the surface of the calcium carbonate and a chemical reaction happens. Okay, so as you can see, the collisions are happening. Now, when we look at the larger lump, we can see that only the outer surface of this calcium carbonate chip or this lump is exposed to react with the hydrochloric acid. Only the outside bit, which means the calcium carbonate on the inside is not exposed. So reactions would not take place on the inside. They would only take place on the outside. The smaller lumps have a larger surface area. More of the surface area is exposed, which means when I draw the hydrochloric acid particles, there is more points of contact between the hydrochloric acid particles and the calcium carbonate particles. So as you can see, they can collide with much more of the surface of the calcium carbonate particles. This means we get a higher frequency of collisions. I'm going to write that here. Higher frequency of collisions. This means that collisions happen more often. Higher frequency of collisions when you've got a larger surface area. And if you've got a higher frequency of collisions, then you have a higher chance of successful collisions. And this is what leads to chemical reactions. Okay, now if we look at what happens, then after a while, the big lump will have, some of it will have reacted. But as you can see by this diagram, only the outside surface has reacted. Only the outside surface has reacted. So some of the particles around the outside have reacted, the inside have not. That is also true for the smaller lumps, but much more in total will have reacted. So the smaller lumps have all decreased in size because they have all reacted like this. So the surface in total all of the outside of the particles have reacted. So in total, much more of the substance has reacted. Right. So let's just summarize. On the large particle, only the outer surface has reacted. This means the inside has not reacted. And this is because there is less surface for collisions. Over here, just going to get rid of this red. Over here, it is also true that only the outer surface has reacted. It is also true. But in total, there is more surface for collisions. So there is more surface for collisions in the small particles, which means there is more successful reactions. And this is because this one has a smaller surface area and this one has a larger surface area. Okay, now let's just go through, summarize what the story is for each one. For the big lump, the smaller surface area has less solid exposed, less surface exposed. So what? Who cares? Well, if there's less solid exposed, then there is less surface for collisions. Less surface available for collisions. And this means that there is a low, and this word is really important, I'm going to highlight this, there is a low frequency, which just means how often they happen. So in other words, collisions happen less often. So there's a low frequency of collisions. It's not good enough to just to say, oh, there's more collisions, or in this case, there's less collisions. The key thing is that they're slower, they're less often. They happen less times in a certain amount of time. So in 10 seconds, you would have less collisions happening here. Okay, and if that's true, then the chance of successful collisions increases, or decreases, sorry, and we have a lower rate of reaction. So for the larger lump, they have a smaller surface area, less solid is exposed, which means there's less surface collisions for collisions. This leads to a lower frequency of collisions, and this causes a lower rate of reaction. So I'm just going to put a box around that at the end, lower rate of reaction. Okay, so what I'm going to do is I'm actually going to get you to pause the video and take down this summary here. Okay, so pause the video, take down this summary. All right, what about the little lumps, broken up, crushed up pieces? Well, they have a larger surface area. So what does this mean? This means that there is more surface exposed, or more of the solid is exposed. More of the solid is exposed, and this gives more surface for collisions. More surface for collisions, smaller pieces, more surface. So what? Well, I'm going to use that important word again. This gives us a high frequency, which just means often, high frequency of collisions. So collisions happen more often. I'm going to highlight that word again, high frequency of collisions. And this gives us a higher chance of successful collisions if they're happening more often, and that gives us a higher rate of reaction. Higher rate of reaction. In other words, the reaction will be more quick, will be faster. Okay, so again, I'm going to get you to pause the video and take down a summary of larger surface area. All right, you're ready to do some questions now. Let's have a look at some practice, more practice questions. We're going to take a look at these. So I want you to pause the video and I want you to do questions 1, 2, 3, and 4 for me. Okay, so you should only be watching if you finish questions 1, 2, 3, and 4. Let's have a look at what you should have. Well, you had to complete the sentences in question 1, 2, 3, and 4. So let's have a look at number 1. And again, you should only be watching if you've got these done. If you've not got them done and you're just waiting to see what I write, then you're wasting your time. You've got to have a go. You've got to put pen to paper. Be an active learner. Okay, so smaller particles have what? The smaller particles, if you like, it's like comparing the big lump to the little lumps. Smaller particles have a larger surface area. Or you could say smaller particles have more surface exposed, which means the same thing really. It's just a different way of saying it. So either one of those would be good. If you said smaller particles have a faster rate of reaction, then technically that's true as well, but you're skipping a few steps there, okay? You're putting two big ideas together, but you're skipping a bit in the middle. So we need to talk about the surface area here, the amount of area exposed. So smaller particles have more surface exposed. Number 2, the lower the surface area, the frequency of collisions. So what happens to the frequency? I'm going to keep highlighting this word so that you know how important it is. Okay, so the lower the surface area, the lower the frequency of collisions. Okay, so if you think about the low surface area, these are like the big chip. Low surface area is the big chip, and that means there's going to be less collisions. So the lower the frequency, because it's less often that they happen. What about this one? High number of collisions means something chances of successful collisions. So if there's a lot of collisions, is there more chance or less chance of successful collisions? So if you haven't written more or less, pause the video and fix it now. Or higher or lower is also okay. Okay, so pause the video and make sure you've got something like that done. Okay, so higher number of collisions means higher chances of successful collisions. Higher or more. Higher or more is both are both correct. If you said less or lower, then obviously that's wrong, because more collisions, more chance of successful collisions. It's just by chance. If they bang into each other more, then it's more likely that they're going to collide successfully. If they're not colliding very often at all, then there's not much chance of a successful collision. So higher or more. What about number 4? Low number of successful collisions means something rate of reaction. Okay, so low collisions, low number of successful collisions. What does that do to the rate of the reaction? So it's going to lower the rate of the reaction. So less collision happening, slower reaction. So it means lower or slower rate of reaction. Well done. If you got that right, good job. All right, let's have a look at number 5. If the surface area increases, what will happen to the steepness of the curve on a rate of reaction graph? So you have to think back to video number 2, where we looked at the graph of the reactants or the products changing as a reaction occurs. So you have to think of that. If the surface area increases, think about what that's going to do to the rate, and think about what that's going to do to the rate of the graph, or the line on the steepness of the curve. Okay, so pause the video and write down an answer to that now, please. Okay, so really quickly, remind you what this graph looked like. I'm just going to get a quick ruler out just so that it's like somewhat tidy. I'm only sketching the graph. I'm going to put a y-axis and x-axis there. Okay, and here I'm putting time, and here I'm putting concentration. Now, you guys should know what this, I'm just going to shorten the word concentration to conc. That means concentration. You guys should know what I'm doing here, because you should have watched that graph or that video already. I'm going to show how the volume or the concentration of products changes over time. So here we go. Here's a red line showing the products going up, 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 and leveling off, and then becoming, stopping to change. All right. So this here is showing products. And the question is, if the surface area increases, what will happen to the steepness of the curve on a rate of reaction graph? Well, if the surface area increases, that's going to make my rate of reaction higher or lower. Speak your answer to the screen. 1, 2, 3, go. Okay, so if my surface area increases, my rate of reaction gets higher. It goes up. So if my rate goes up, what happens to the steepness of the graph? Okay, so the steepness of the graph is going to increase. It's going to get more steep to show it's happening more quickly. So here I'm going to draw a line. No, actually, I'm not going to draw a line because you have to do that in the next question. I would describe it as getting more steep. It gets more steep. Okay, that's what happens. All right, so it gets steeper. Now, I want you to look at that graph and imagine what that would look like if it got more steep. What would happen to the curve? So you need to imagine that because you're going to be doing it in a second. All right, next one. Pause the video and do number 6. Okay, so yeah, just to clarify what the answer should be, we would say the curve is more steep, or the curve is steeper. The curve is more steep. Well done. If you said that, good job. Okay, and the last one, number 6 here, says sketch a graph, put time on the x-axis and concentration on the y. So go ahead and do that, put time on the x and concentration on the y, lay it out. It's just a sketch like I've done, get a ruler, do an x and y and put time on the x and concentration on the y. Do that now. Okay, so you should only be watching if you've got your graph laid out. Now it says use 2 curves to show the rate of the reaction with the small surface area, which is the large lump, and a substance with a large surface area, small lumps. So use 2 different colors to draw the curve for each one. Pause the video, do that now. Okay, so you should be only watching if you've done this. I'm going to use this one that I've already started over here, time and concentration. I'm going to say that this red line shows small lumps. Small lumps. And small lumps means low. No, sorry, this is large lump. Apologies. This is large lump. Large lump. And you should label yours as well. Large lump means low SA, which means surface area. I'm then going to use a blue one to show the small lumps with the large surface area. So what will it look like? You should have this done already. So it starts in the same place. It starts at 0 and it goes up, it increases, but this increases more steeply. And it's still going to go up. The total concentration is going to be the same. There's not going to be any more of it at the end. It's just going to get there quicker. It's going to take less time to increase. Now, that's not a very good, nice straight curve. That's terrible, actually. I'm going to fix that. I need this to be a little bit less squiggly. So there we go. That's a bit better. Okay. So the blue line here, this shows me small lumps. Small lumps means a large SA, surface area, and a large SA surface area means it's going to react more quickly. And I know that it's more quick because the graph is steeper. So steeper graph means faster rate of reaction. So excellent job. Well done if you got that right, or if you got it mostly right, well done. Make sure you do have the 2 lines labeled, because without a label on it, if someone comes and looks at your graph, they're not really going to have any idea what it shows. So make sure that you have the blue line labeled and the red line labeled with some to explain what's going on. All right, last little bit we're going to take a look at is these couple of questions. Okay, so I want you to look at these questions, and what we're going to do is we are going to check the question, and then I've given you a sample answer. And we're going to talk about why it's a good answer or how it could be improved. Okay, so let's have a look at question 1. A student investigated the rate of reaction between calcium carbonate, which are marble chips, and hydrochloric acid. This is the exact same thing I talked about in the beginning when I was drawing the diagrams. Explain in terms of particles and collisions. Okay, so look what it's asked us to do. Explain in terms of particles and collisions the effect of increasing the surface area of the marble chips. Okay, and explain the effect it has on the rate of reaction. So if we increase the surface area, what effect does it have on the rate of reaction? The sample answer is shown in red. What I want you to do is just have a quick read of it yourself. Okay, I want to talk about this answer. Is it a good answer, and why is it a good answer? Well, the first of all is I would say it is a good answer. Okay, this is a good answer. So you've read it there yourself. Why is it a good answer? It's a very good answer because it talks about this here, which I've told you how important that is, to talk about frequent collisions. Okay, so the rate of reaction is increased. I'm going to read the answer. The rate of reaction is increased. This is because more particles are available to collide, resulting in more frequent collisions. So this is a really good answer because they talk about the frequency of collisions, whereas some students would just say there's more collisions. But the important part is that there's more collisions in a shorter amount of time or the same amount of time. So yeah, we have to say that the more often or the more frequent. That's what leads to the higher rate of reaction. Okay. Students sometimes also actually forget to say what happens at the rate of reaction. So the fact that they started off by saying the rate is increased, that's a good way to start. The rate is increased, and then after they explain why, and they definitely mention frequency of collisions. Let's take a look at a second example. A little bit more going on. So here it says dilute hydrochloric acid reacts with sodium carbonate. Same reaction again. The word equation for this reaction is, and you see the word equation, have a read of it there. It's not really that relevant here anyway. What's relevant is the diagrams. Let's have a look at the diagram. The diagram on the left shows the apparatus used by student X to investigate the reaction, and the reaction on the right shows what student Y did. Now look at A and B. What's different about them? Look at the sizes of the pieces. Okay, now look at part 2 down below. Both students X and Y use the same volume of acid, the same concentration of acid, the same temperature, and the same mass of sodium carbonate. So they're keeping all these things the same. The only thing, it says then use the diagram to explain why the rate of reaction that student Y carried out was faster. So student Y, this is student Y, and this is student X, by the way. Why is Y's faster? Well, as you can see, Y has small pieces of sodium carbonate, whereas X has large lumps of sodium carbonate. So Y has a smaller particle size, smaller pieces, and that means that the surface area is greater for Y. Let's read the answer. Have a read of the answer that this student wrote. Okay, read it in red. Okay. This answer correctly references the most important ideas that it says that the reaction was faster, so that's good. Student Y's reaction was faster, so they're clarifying that. And because the pieces of sodium carbonate were smaller. So I like what they've done there. They've said that the particles are smaller. Now, they've said this meant that there were more collisions and a greater rate of reaction. The part that I don't fully like about this is that they've just said there were more collisions. They haven't referred to frequency. So they haven't said that the reactions were more frequent. There were more frequent collisions, or the collisions happen more often. They forgot to actually state they forgot to actually state why that's important. Okay. So they've correctly identified the effect that student Y's reaction was faster, but they did not specify that there were more frequent collisions. They also did not specifically mention that the smaller pieces of sodium carbonate meant that there's a greater surface area. So nowhere in here have they actually said, so they've said that the pieces of sodium carbonate were smaller. Look at this, they've said the pieces of sodium carbonate were smaller, but so what? They've left out that this leads to a greater surface area. That's a really important idea, the greater surface area, and the frequency of collisions is a really important idea. So this answer can definitely be improved, okay? So just have a look through it one more time with the advice that I've put in. They haven't mentioned that the smaller particles lead to a greater surface area, and they haven't said that more collisions, they haven't referenced that we should have more frequent collisions, not just more collisions. And they have said that it leads to a greater rate of reaction, which is good. All right, now I've got 3 more of these for you, and what I want you to do is pick them apart and tell me what's good about them and where they could be improved. Okay, so here's 3 questions related to surface area, and you have to assess each one and see how it could be improved. Is it a good answer, and how could it be made better? All right, so what I want you to do is I want you to pause the video and I want you to say why they are a good answer, but why they could be improved. None of them are bad answers, you know, but they're definitely not, they don't have the full detail they need to. Pause the video and do that now, please. All right, let's look at the first one. Hopefully you've had a look, and let's see what do we like about it. Okay, so in the first question, the answer there says chewing food into smaller pieces gives a larger surface area. So I like that they've mentioned the larger surface area, okay? This results in, and they've also mentioned that it breaks it into smaller pieces, so that's good. This results in a greater rate of reaction. That is true. Smaller pieces will give a greater rate of reaction. Okay, so they've mentioned surface area and the rate of reaction and smaller pieces. What have they not mentioned? Okay, so it could be improved by, this answer could be improved. This is what you should be writing. This answer could be improved by ... Well, what could we say? Well, we mentioned that we should definitely be talking about, we haven't mentioned anything about collisions. There's no mention of collisions. Okay, so what could we say then after smaller pieces results in a larger surface area? So we could say this makes it more surface for collisions. And what does this do? This increases the frequency of collisions. So they haven't mentioned this word that I told you was really important, the frequency of collisions, how often they happen. So nowhere here have they said that breaking it into smaller pieces makes more surface for collisions, and this increases the frequency of collisions. All right, so hopefully they are things that you managed to spot there. Or definitely if you spotted one of them, good. Hopefully you've spotted 2 of them. All right, let's have a look at B. A student leaves an iron nail and some iron wool out in the air. Which will rust quicker? And the answer was the iron nail is made of smaller bits, so will have a greater rate of reaction. Well, first of all, is that true? Does the iron nail have smaller bits? And I would say it doesn't. We've already seen that iron wool, like what we've seen earlier, do you remember this picture over here? We said that the iron wool is actually smaller pieces. So the student's answer, this is actually quite a bad answer because it's completely wrong. A student's a nail is made of smaller bits. It's not. It's made of larger bits. The wool is made of smaller bits. Okay. They also have not referenced at all anything about surface area or collisions. So there's nothing about surface area, collisions, frequency of collisions. Can all be added here. And they've also gone with the wrong thing in the beginning. Okay, so the iron nail, definitely not. It would be the steel wool, or the iron wool, sorry. Iron wool has smaller bits. And I don't really like that word, that bit either, smaller bits. It's not very specific, okay? So we could definitely improve that. All right, let's have a look at the last one. The student wishes to investigate the rate of reaction of marble chips with acid and different temperatures. Explain why the student must use the same size chips for both experiments. Okay, so they want to see how does temperature affect this reaction. Why must they use the same size chips for both experiments? So it says different size chips will have different rates of reactions due to more collisions. So what's good and what's not right about that? Well, different size chips will have different rates. That's probably true. They will have different rates. We like that. That's good. Due to more collisions. Due to more collisions. Again, no mention of surface area. surface area. So we could say different sized chips will have different surface areas, and this will change the surface available for collisions. So I definitely want to be mentioning collisions, and we also want to be mentioning the frequency of collisions. So if there's more surface available for collisions, there will be a greater frequency of collisions. None of this has been mentioned in this answer, which means that it's not really as good as it could be. They haven't mentioned surface area. They haven't mentioned more surface available for collisions, and they haven't mentioned the frequency of collisions. Yes, they do have that the rate will be changed. Oh, they do have, I suppose they do have more collisions, but that's not really specific enough. They haven't mentioned surface area, haven't mentioned frequency of collisions. So answer can definitely be improved in those ways. Okay. All right. So well done. If you spotted those kind of errors there, or if you spotted ways you could improve those answers, that's fantastic. If you could do that, then that's probably putting you on the step to writing better answers yourselves. All right, that's it for today's video. You hopefully now could explain in detail why surface area will affect the rate of a reaction. So basically, smaller pieces means more surface available for collisions. So surface area is really important. So greater surface area means more surface available for collisions and a higher frequency of collisions, which leads to a higher rate of reaction. All right, guys, that's it. I'll see you in the next one.